Hello, welcome back. This video we are going to focus on bond polarity, dipole moment, and then we are going to use this idea or this concept to determine whether the molecule is polar or non-polar. Before we can determine the polarity of a molecule, we need to know that there are two types of covalent bond. One is polar covalent bond, at where the difference of the electronegativity is in between 0.5 to 1.7, while non-polar covalent bond is less than 0.5. Besides looks at the difference of the electronegativity, the shape of the molecule also will influence the polarity of a molecule. Okay, let's take one example, hydrogen fluoride, which is a polar covalent bond. Okay, we have two ways to express. This is the first way, and then this is the second way. So the first way, we are going to use the symbol partial positive and partial negative to show that which is more electronegative. So as we know, fluorine is the most electronegative element. So that's why we will give it a partial negative. While for the another one, we are going to use the arrow to show that actually the electron is pulled towards the fluorine, which it is more electronegative. Okay, after knowing about the bond dipole, then now we are continue with the meaning of dipole moment. So what is the meaning of dipole moment? This is the question asked in tutorial question number 3A. So basically the dipole moment have a symbol which we call is mu. It's a quantity measure of a polarity of a bond. So simplify to say it is we are going to use the charge multiply with the distance. Okay, so bond dipole is showing that the bond, which part is the positive end and then which part is the negative end. Okay, so just now we use the example hydrogen fluoride, and then the arrow is pulled towards to the fluorine, which show that fluorine is more electronegative. So if the electron is moving, so means that there is distance. So when you multiply with the charge, the mu or the dipole moment will not equal to 0. If the dipole moment is not equal to 0, then it is a polar molecule. While if the atom didn't moving or the distance is equal to 0, so no matter what is the charge, the dipole moment always equal to 0, and this means that it is a non-polar molecule. So do bear in mind that bond dipole is not equal to dipole moment. Simple to say, bond dipole only focus on the bond, while dipole moment we are consider all the bonds in the molecule. All the bonds, the resultants of the bond dipole for all the bonds in the molecule. To determine the polarity of a molecule, as usual, step number 1, we need to draw the fluid structure. After we draw the fluid structure, based on the bonding pair and also lone pair electron, we're able to determine the basic shape and hence we're able to determine the molecular geometry. Based on the molecular geometry, if the geometry is symmetry and all the terminal atoms are similar, then the compound will consider as non-polar molecule. This is the summary of how we determine the polarity of the molecule. So basically these are the shapes that we learn in the part of molecular geometry. If there is two if there is two bonding pair electron, the shape is linear. If three electron pair, three bonding pair, trigonal planar. Four bonding pair, tetrahedral. Five bonding pair, trigonal bipyramidal, and six bonding pair, octahedral. All these 5 basic shapes are considered as basic shape, or they are symmetry. Okay, besides from this, basically we also will notice that linear which is from the make up from 2 bonding pair and 3 lone pair, also considered as symmetry. Okay, 2 bonding pair with 4 lone pair, also symmetry. And the last one is square planar, 4 bonding pair with 2 lone pair. So all the shape with the tick here is considered as symmetry. Now let's continue with the tutorial question number 3b. Based on each of the following given, PCR3, PCR5, and also POCR3, draw the Lewis structure. So this is the Lewis structure for PCR3, PCR5, and also POCR3. Done for part 1. Second, we are going to name the shape based on the molecular geometry and also predict the bond angle. In this question, because it is only mentioned name the shape, so we don't need to redraw the structure in the molecular geometry. It's okay. So again, before we can determine the shape, we have to know the basic shape. So the basic shape for PCl3 is have 4 electron domain, so it is tetrahedral. And then this tetrahedral shape have 1 lone pair, so the geometry is trigonal pyramidal. And the bond angle will be less than 109.5 degree. While for the PCl5, there is 5 electron domain, so the basic shape is trigonal bipyramidal. Since there is no lone pair electron, so the geometry, molecular geometry, also trigonal bipyramidal. And then the bond angle, there is 2 bond angle, 90 and 120 degree. So the next one is for POCR3, which is have 4 electron domain tetrahedral. So again, the POCR3 has no lone pair electron, so the molecular geometry is similar with the basic shape, and the bond angle is 109.5 degree. So we settle for part 2. Number 3, we have to state whether this molecule is polar or non-polar. With a quick check, as long as the compound is symmetry and with similar symmetry and with similar terminal atom, we will consider they are non-polar molecules, similar terminal atom. So in this case, trigonal bipyramidal and also tetrahedral are basic shape, which are symmetry. So and then when we check the terminal atom for PCl5, all the terminal atoms are similar, so that's why this is non-polar molecule. While for the POCl3, even it is basic shape symmetry, but the terminal are different because there is 1 oxygen and 3 chlorine. So this molecule is polar molecule. While for the PCl3, because there is presence of lone pair electron, so this molecule also will consider as non-symmetry. So if it is not symmetry, so this molecule is polar molecule. Now let's continue with tutorial question number 4. The reaction of xenon with fluorine will form xenon tetrafluoride. Draw the structure of the xenon fluoride. So as usual, step number 1, we are going to calculate total of number of valence electron. Xenon has 8 valence electron, fluorine has 7 times 4, 28. So total is 36 valence electron. Xenon is the terminal atom. So there is 4 terminal atoms, so 8 times 4, 32. So have extra 4 electron. So basically, I will know there are 2 lone pair electron plus 4 bonding pair electron. So the basic shape for this compound is octahedral. So with 2 lone pair electrons, so I will have the idea that the shape for this element is square planar. Okay, don't forget to complete the lone pair electron at the terminal atom. So you can double check again. We have 4 terminal atoms. Each terminal atom has 8 electrons. So minus 32, and then we have extra 4 electrons. We'll place at the central atom. So we have done for the structure, Lewis structure of SEF4. Next one, we are going to predict the polarity of the bonds and also molecule. So it means that we have 2 parts for this question, and then we are going to explain it. Okay. So first we are going to predict the polarity of the bond. So you are going to mention the bond between Se, xenon and fluorine is polar bond. Why we know that they are polar bond? Due to different electronegativity. Okay, and then these bonds are arranged. These Se, xenon, fluorine bonds, all these 4 bonds are arranged symmetrically, okay, which fulfill the first requirement of the criteria. Okay, because of they are arranged symmetrically, and then from the similar terminal atom, so the bond dipole can be cancel out each other. Once the bond dipole can be cancel out each other, which means that dipole moment equal to 0. And once the dipole moment equal to 0, this molecule SEF4 is a non-polar molecule. Continue with question number 5. ICl2 plus is polar, while ICl negative is non-polar molecule. So explain. So again, before we need to explain, we have to have the Lewis structure. Iodine 7 valence electron, chlorine also 7. So total is 21 plus, show that it is going to lose 1 electron. So ICl2 positive, total at 20 valence electron. So because here it's showing there are 2 terminal atoms, so I'm going to minus 16. Each terminal atom 8 valence electron. Remaining at 4 valence electron means that there is 2 lone pair electron. So 2 lone pair plus 2 bonding pair. So the basic shape is tetrahedral. But then because of 2 lone pair, so basically we know this one, the shape of the molecule will be the V shape. So place the terminal atom with 8 valence electron, and then 2 lone pair will be at the central atom. So this is the Lewis structure. Next, we are going to continue to explain why these are the polar molecule. So as usual, first we are going to mention the bond between iodine and Cl is polar bond. Okay, and then there are lone pair electrons, which cause the V shape is not symmetry. So once the V shape is not symmetry, so means that the bond dipole cannot be cancel out each other. So dipole moment is not equal to 0, and this molecule is polar molecule. Next question, we continue with ICl2 negative, iodine 7 valence electron, chlorine also 7 times 2, 21, negative means gain 1 electron, so total 22 valence electron. So again, there is 2 bonding pair, so minus 16. Then we have 6 valence electron, means that we get 3 lone pair plus 2 bonding pair. And from here, we know that the basic shape is the trigonal bipyramidal. With 3 lone pair, so its molecular geometry will become linear. So I, Cl, and Cl. And then we have 3 lone pair electron. So this is the Lewis structure together with the molecular shape of ICl2 negative. So according to here, chlorine is more electronegative, so the bond dipole is altered to C chlorine. So again, we will going to mention the bond between ICl is polar bond due to different electronegativity. Okay. Then second, we are going to mention the bond dipole of ICl, bond dipole can be cancel out each other due to the symmetry structure. Okay, so this symmetry structure, because we know the shape is linear. So once the bond dipole can be cancelled out, the resultant dipole moment will be 0. So the molecule is non-polar molecule. Tutorial question number 6. Compare the polarity for the CCl4 and also POCl3. Again, start with the Lewis structure. Carbon have 4 valence electron, chlorine have 7, so total is 32 valence electron. There are 4 terminal atoms, so minus with 32, so there is no lone pair electron. So basically, CCl4 consists of 4 bonding pairs, and where the structure will be in the form of tetrahedral. Complete each terminator with the atom. Then next one, we will continue with phosphorus 5 valence electron, oxygen 6 valence electron, chlorine have 7, 31 plus 11, so again it is 32 valence electron. So in this case, POCl3 also is arranged in tetrahedron. Okay, so basically both of these compounds has the molecular geometry of tetrahedron, but we will say that CCl4 is a symmetry molecule, while POCl3 is a symmetry molecule. Okay. This is because all the terminal atoms same, and then the bond dipole can be cancelled out. Once the bond dipole can be cancelled out, the dipole moment equal to 0, and this molecule is non-polar molecule. So the other ways happen to the POCR3 because the oxygen is more electron negative than chlorine. So bond dipole cannot be cancel out each other, and then dipole moment is not equal to 0. So this molecule is polar molecule. Last question in tutorial 4.2, question number 7. Boron hydride BH3 with ammonia will react with the ratio 1 to 1 to form a product. So basically we already have idea. This is the Lewis structure for the boron hydride with 6 electrons, while ammonia consists of 3 bonding pairs with 1 lone pair electron. So when the ratio here is 1 to 1, so means that they will form a compound at where the lone pair electron from nitrogen will be shared with the fluorine to form negative bond. So again, the question is asked us how the bond can be formed. So we are going to mention that one lone pair electron from nitrogen is donate and share with boron. Okay, this is answer for question 1. While for question number 2, what type of bonding is formed? So the answer is dative covalent bond, because the electron only contribute by 1 atom. What happened to the bond angle in ammonia and BH3 after forming the product? Explain. So this one we will continue in next slide. Question number 3, we have to mention about the bond angle after forming the product. So before forming the product, BF3 have 3 bonding pair or 3 electron domain. So the basic shape is trigonal planar with the bond angle 120 degrees. While ammonia have 3 bonding pair plus 1 lone pair with 4 electron domain, at where they supposedly will be arranged themselves in tetrahedron for the electron pair. Due to the lone pair electron is persist, so the shape will become trigonal pyramidal, and then the bond angle is 107.3 degree. Okay, so for this ammonia, we are not accept the answer less than 10.9. Okay, because ammonia is one of the molecule that we previously learned about the bond angles. So after the formation, so again we focus on the boron. So now in this case, the boron consists of 4 electron domain, which is 4 bonding pair. So will lead to the shape of tetrahedron. So means that the bond angle is 109.5. Same case happened to the ammonia. The nitrogen in the ammonia is also consists of 4 bonding pair, and there is no lone pair. So that's why the bond angle also is 109.5 degree. Okay, let's have a quick check again. When there is 2 pair of electrons which arrange themselves in the linear shape, it is symmetry, so non-polar. Trigonal planar, also non-polar. Tetrahedral, trigonal bipyramidal, octahedral, and beside from the 5 basic shapes, do remember that square planar also non-polar, because all these shapes are considered symmetry. Again and again, Besides from the shape, we have to consider the terminal atom. Have to make sure all the terminal atoms are similar. Summary in how to identify whether the molecule is polar or non-polar. Basically, we try to check is the bond is polar bond or non-polar bond. So if it is non-polar bond, the molecule basically is non-polar molecule as well. Okay, but if it is polar bond, then you have to check is the shape is symmetry. If your answer is no, so the molecule is polar molecule. If the shape is symmetry, then you are going to ask, is it all the terminal atoms are similar? Similar terminal atoms. So if your answer is no, the molecule is polar molecule. But if your answer is yes, then the molecule is non-polar molecule. Okay, so I hope this summary can help you in determining the polar and non-polar molecule. Okay, these are the final answer for objective question tutorial 4.2, and then this is also the simplified question answer for tutorial question number 3 up to question number 7. Thank you for watching this video. Hope it is helpful and see you again.